Hello and welcome to Xamarin University. My name's Kim Philpotts and this is XAM140 Resources and Styles. Before you continue, you should download the course materials available from university.xamarin.com. This course shows you how to use resources to eliminate repeated XAML. We have 4 objectives. The first one will be to remove hard-coded values for things like fonts and colors, and to define them as resources so you can have a single copy that's easier to update. Then we'll look at consolidating groups of property values into styles, which will be able to apply to a control as a single unit. In our third objective, once we have our resources defined, we can start thinking about organization. So are the resources needed only for a single page or across your entire application? And here we'll see how to handle both situations. Lastly, operating systems generally let the user select a few system-wide display preferences, the most obvious one being text size. So in our last objective, we'll have a look at how to incorporate those settings into our application. By the end of the class, you'll be able to use resources and styles to remove repeated XAML and to create a consistent UI across all the pages of your application. The first thing you'll do is to remove hard-coded values from things like fonts and colors. And a rough analogy from C# would be using const and read-only fields to create symbolic constants. We'll first spend some time discussing the motivation, and then we'll have a look at how to use XAML resources for unchanging values. This is the part that's analogous to C# const. Then we'll see how to handle the case where the values change over time. Duplicate values often occur in XAML for things that define the look of the UI, things like fonts and sizes and colors. And duplicate XAML is bad for a number of reasons. First, it's difficult to update values in multiple places, and it's also hard to achieve consistency. So for example, if you've got 20 pages in your app, it's easy to accidentally use the wrong color or size in at least one of them. Our first exercise for the class is to have a look at an existing application that contains some repeated XAML and hard-coded values. And what we want to do is see if we can identify the problems and identify some opportunities for improvement. We aren't actually going to write any code, we're just going to have a look at some existing XAML. And this is actually exercise 1 in your downloadable class materials. So let's flick over and open the tip calculator app from the class resources. If we go over to our lab materials folder and then into part 1 resources, then lab start, tip calculator, and open tipcalculator.sln. So let's go and have a look at the standard tip page.xaml file. And so what we're looking for is repeated XAML and hard-coded values. And some good examples are the background color on the grid, which is hard-coded to silver. Let me just pump up the font size a bit. Also, we can see on each of the labels we're repeating values. So for example, text color, which has been set to navy for each of these labels. Also, our font size is repeatedly hard-coded, and even our font attribute of bold. So these are all classic examples of repeated XAML values and hard-coded values. And these will make your XAML really hard to maintain over time. For example, if you wanted to change the label color, you'd have to identify each of the locations and hope you find them all and then change them manually, which is not ideal. So in a moment, we'll come back here and have a look at fixing this up a bit. But first, let's talk about how we can create resources to help us out. A resource is any object that can be shared across your UI. You define a resource once, and then you can apply it to many places instead of using a hard-coded value. And this makes maintenance easier since the value will only actually appear once. So in the code on this page, we want to only have the colors and fonts defined once in a resource, and then use a reference to the resource throughout our application. Then, if it needs to change, you can just do it in one place and update your entire application. So in order to do this, we're going to use a resource dictionary. The library class resource dictionary is a dictionary hard-coded to map strings to objects, and it's similar to a system.collection.generic.dictionary, but it has a small amount of customization to hold UI-specific values, for example implicit styles. It has a number of uses which we'll look at over the upcoming objectives, and you can see it's actually got a couple of add methods. One which takes a string key and an object value, as you'd expect, and another one which is a bit more interesting because it takes a style and generates a key internally from the fully qualified name of the styles target type. And we'll talk about styles a little bit later on. But apart from that, it's pretty much just a normal dictionary. Resources on a page are so common that each page has a built-in dictionary, and it's primarily used for XAML. However, there are a few cases we'll see later where you need to access it from code. The page's resource property will be null by default, so you do need to create a resource dictionary object. We can do this by using a bit of XAML that you can see here on the slide. Resources are most often created in XAML. You declare them inside a resource dictionary, and when you're adding to a dictionary, you need to specify a key and a value. So you use x:"key to set the key, and the object you create becomes the value. So in the slide here, we're creating a resource of type thickness with a key of my key and some values. It's worth noting you should probably name them based on what you're going to use them for rather than the actual value. That way, when you look at a resource, you can see it's, for example, background color, but if you set it as red color, you might not know where you're using it. Once you've got a resource and some values in it, you can use the StaticResource markup extension to look up a resource in a dictionary. You provide it the key and it returns a value. Property settings that use static resources are static, so the lookup happens once when your target object's created, and the target property is not updated if the value in the dictionary changes. So we're using a static resource here, but there's also another type of resource, and that's a dynamic resource. And these will update the UI in real time if the value in the dictionary changes, but we're going to cover these a little bit later on. It's also worth mentioning that static resource will throw a runtime exception if the key isn't found. Resources are often used for things like font size, which are actually type double. So XAML natively supports many of the C# simple types and provide keywords that make it easy for you to create instances in your XAML. So you can use these XAML intrinsic types to set up dictionaries that contain things like strings and doubles. Some examples of this are things like border width, which is a double, or border radius, which is an int, font family, which is a string, and the bottom, left, right, and top, which are doubles, or even isPassword, which is a bool. You use these values just like you'd use constants in your application. Resource dictionaries map strings to objects, so they can actually store anything you need, even on-platform objects. So you could have an entry like the one in this slide where you actually specify different text colors on different platforms. So let's have a look at our second group exercise for the class today. And in this exercise, we're going to use page level resources to eliminate repeated values in XAML. In fact, what we're going to do is go back to that page we saw in our first group exercise, and we're going to fix that up a bit by using page level resources. So let's just flip back over to that code. And we'll start out by creating a resource dictionary object for the page. And then inside there, we'll add a new resource. We'll add a color resource called background color or BG color, and we'll set that to be white. We'll also add another color resource, this time a foreground color. We'll call that FG color and set that to be black. Now let's go and apply this to the grid using a static resource markup. So instead of the hard-coded silver value, we'll use static resource BG color. And now we can go down to our labels and we can add the foreground color, FG color, to the text color of all our labels, again using the static resource markup. We'll apply that to each of the labels. Now we can run the application and see what we get. So we can see we have a white background and we've got these labels. So now let's just see how easy it is to change them. So let's change the background to yellow and the foreground to green. And we'll start that application again and see what we get. And we can see that's changed the background color and it's changed the foreground color of all those labels. Okay, so we could do something similar with the font size as well. Okay, but this time we're going to have to use a double value because the font size is a double. So we'll put in a resource of x:double and give it a key of font size and set its value to be 32. And then again go down to the labels and apply a static resource to use the new font size resource. And copy that to the other fields as well. And now we'll run that and see what we get. And we should see that our labels are all now a lot bigger. And there we go. So you can see by using these resources, it makes it a lot easier to change the values throughout your system. Sometimes you might not have the resource values ready when your UI is being created. So for example, you might store your user preferences on a server and load them when you launch. Static resources won't work for this case. If you remember, with static resources, if the key is not in the dictionary, it'll end up throwing a runtime exception. Also, resource values can change while your application runs. So for example, you might use resource values to make user preferences available to your UI, and the user might change those values at runtime. Again, static resources won't work in this case, because the value is assigned once, and it's not updated if the dictionary changes. Your page's resource dictionary is actually available in the Resources property, and in your code behind you can add, remove and update values as you need to. So as you can see in the sample here on the slide, we're able to access the resources via code, and that could actually be pretty handy in a lot of situations. But do remember, in these situations, you can't use a static resource. What you want to use is a dynamic resource. So let's talk about dynamic resources. Dynamic resources actually do two things. First, they load the resource value initially when the target's created, and then it listens for changes on the dictionary and updates the UI property values as required. So in the code on the slide, we can actually see there's a stack layout with a dynamic resource BG assigned to its background color. Then when the code at the bottom actually goes and changes that resource of BG to green, it would actually update the stack layout background color. Dynamic resource is designed to handle the case where a resource value is not actually available at startup. So if the key is not found, dynamic resource actually takes no action. It doesn't try to set a default value, but nor does it throw an exception either. It just leaves it as it is and waits for the value to be present. And once the value is present, it'll go and set it and then update it. You can achieve the same effect as dynamic resource from code by using the SetDynamicResource method. It loads the current value of the specified resource and then watches for change events so it can update the UI. So pretty much the same behavior as a dynamic resource. But this can be a bit more specific than changing a resource value. When you change a resource value, it'll update all the UI properties that are bound to it via a dynamic resource. By contrast, by using the SetDynamicResource method, it lets you modify a single UI property. So now we've had a bit of an overview of static resources and dynamic resources. It's time for the first of our individual exercises. So pause the video here and go ahead and do exercise 3 in the downloadable class resources. So let's summarize where we're up to. We've had a look at using page level resources and also dynamically updating resources. And what we know is that resources will let you define symbolic constants in your XAML. It's quite likely that every one of your pages will end up using this technique. So resources are convenient when setting a single property value, but they can still lead to cluttered XAML if you load the same resource into several different controls. In this objective, We'll consolidate groups of property values into styles, which you can then apply to a control in a single unit. We'll cover the basics of styles first, and then we'll use style inheritance to refactor our XAML. Resources are great to avoid hard-coded duplicate values in your XAML. However, they can be a bit tedious to apply. Each property value needs to be assigned individually, which yields cluttered, verbose XAML. So as you can see in the code above, we have a couple of buttons defined, but it's a lot of work and tedious to set all those properties all the time. In this situation, the only real difference is the text. Wouldn't it be great if you could bundle all these together and just apply them in one go? Well, with styles, now you can. Users are sensitive to startup time, so it's generally considered good practice to be able to minimize the time it takes for your UI to appear. And whilst resource lookup is fast, it still takes longer than assigning a hard-coded value that doesn't require a lookup at all. A setter is a simple library class that stores two things, a property and a value. It's analogous to an assignment statement since it encapsulates the left-hand side and the value that gets assigned. But the property we're setting needs to be a bindable property and the value has to be an object. For the most part, they're pretty straightforward though. A style is a way to group related property settings. The style must be targeted at a specific type of UI view, and the properties in that style must be part of that view type. So for example, you can't set a style targeted at label and include a setter for border width, since that property isn't actually part of a label. So looking at our code, we have a target type in our style and a bunch of setters that define values for the different properties. Styles are shareable, so they're generally defined as resources. You can apply the same style to many different control instances. In other words, a style is something that can be shared, so it's a natural candidate to define in a resource dictionary. You load a style by assigning to the style property. The assignment causes each of the setters to be applied to the target. And using a style has two nice benefits. First, the resulting XAML is a lot cleaner. There's just one property setting instead of several individual settings. It also encourages consistency. If you assign individual properties to many controls over multiple pages, it's easy to miss one of them or to use inconsistent values. The visual element class defines a property named style, and as most controls actually inherit from visual element, the property is widely available throughout the inheritance hierarchy of controls. It's also worth mentioning that you can use DynamicResource to assign a style property. If two styles use the same property value, you can factor the value out into a resource and then apply the resource in the two setters. So that lets the styles share a value which reduces repeated hard-coded values. So in the code on this slide, we have a couple of colors defined and then we use them as values in our style. You can either use StaticResource or DynamicResource for the value of a setter. The two options behave as usual for them, so a static will not update if the underlying resource changes, while a dynamic resource will. Normally, when you add something to a resource dictionary, you must specify both a key and a value. But there's a special case with styles. A style without a key has a special meaning. It becomes an implicit style that is automatically applied to every object of its target type. So in our code, we can see that we have a style for a button without a key, and that's going to be applied to all buttons. But be aware the matching of implicit styles to controls requires an exact match of the types. That is, an implicit style with a target type of visual element will not be applied to all buttons since their types do not match exactly. Let's talk about the order of precedence of styles and property values. So suppose you have a property setting in a style. You apply the style to a control, but then explicitly set the same property directly on the control. The direct setting overrides the one from the style, and the property will take on the value of the direct setting. So for example, suppose you're considering whether to use a style written by someone else, and you don't own the style, and you can't modify it. It could happen that the style is almost but not quite perfect for your needs. For example, it might have 5 setters, 4 of which use values you want, but 1 which isn't quite right. You can go ahead and use a style, but then add an explicit property setting to your control for the setter that has the inappropriate value. Your explicit value will override the 1 in the style. You can write a style that targets a base class. The style can be applied to any of the derived types. Note that this is a different rule than implicit styles. With implicit styles, the types must match exactly. And that's not true here since we're using an explicit application of the style. It's also possible to create a style in code. This is fairly rare, but it can be useful for code-generated UI or when you need the full power of code behind to create, modify, or update a style at runtime. So let's have a look at how we do it. We can create a style specifying the type we want to apply it to, and then we add setters to the setters collection of the style. So let's have a look at an exercise now where we'll use styles. This is exercise 4 in the labs. So go ahead and pause the video now and do exercise 4. It's actually quite common for two styles to contain a duplicate setter. So for example, you might be trying to create a cohesive look for your UI where your controls use a consistent background color. And the background color setting will then likely appear in more than one of your styles. So another case where this can happen, you might want all of your buttons to look basically the same. However, buttons that perform important actions like buy or cancel or submit might be emphasized by using a different border color. You'd have two styles both targeted at button that would contain all the same setters except for one for border color. If you're not the owner of a style, it might not be possible to modify it to fit your situation. You could apply the style to your controls and then add explicit property settings to override the style values you don't want. However, this is a bit tedious to code and results again in repeated XAML. But the good news is a style can be inherited from an existing style, and the new style inherits all the setters from its base. We use Basedon to indicate the style's base. You have to use a static resource to identify your base style. And the target types of the base and the derived styles must be compatible. So they must both target the same type, but the base style's target type can be a base class of the derived style's target type. A derived style will typically want to modify its base. It can extend its base by adding a new setter that didn't appear in the base, or it can customize the base behavior by including a setter for the same property as a setter in its base, and the setter in the derived style will override the one in the base. Let's do another quick individual exercise, and this time we'll be looking at investigating style inheritance. So feel free to pause the video now and complete exercise 5 in the lab materials. So let's quickly summarize styles. So styles let you create a collection of property values and then load them into a control as a single unit. Styles are extremely common in apps that provide a custom look, and you could easily end up with one or more styles for each type of control that you use in your UI. And once you start making heavy use of styles, you'll probably want to use style inheritance to avoid repeated setters. Our next objective is to make your resources and styles available across your entire application. In order to do this, you'll need to store them in a central location and not define them within a page like we have up until now. First, we'll create a global XAML file to hold our shared resources, and then we'll move some resources and styles to the new file and see that they're available across all our pages. Resources defined in a page's XAML file are only available to that page. And since most apps have more than one page, page-level resource dictionaries are not really sufficient to avoid repeated code. Resource dictionaries are included in classes all the way throughout Xamarin.Forms UI. The visual element class defines a resources property, and this class is near the root of the UI hierarchy, so controls and pages and layouts all inherit from visual element, so they all have a dictionary. The application class also defines a resources property, but application does not inherit from visual element, so it defines its own. Resources can be defined in many different places and at many different levels. You decide where to place a resource based on where it's used. So in practice, page and application are probably the most common location for resources. So things that only need to be on one page are generally defined in that page, and things needed on multiple pages go into the application. Let's talk about the lookup rules now. So here we can see how it navigates up the hierarchy to look up resources. The visual elements on a page form a tree structure, often called the visual tree, and each element in the tree has its own dictionary that might contain resources. So the resource lookup process is search the dictionary of the element to which the resources are applied. So for example, if you set the background color of a button, the button's dictionary is searched first. Then we search up the visual tree, and then we search up the application-wide dictionary. The search stops as soon as a matching key is found. If a matching key can't be found, it depends on how the resources are applied on what will happen. For a static resource, it'll throw an exception, but for a dynamic resource, it does nothing, but it isn't considered an error. So where do you declare application resources? Well, to define an application level resource in XAML, you need a XAML file associated with your app class. And currently the project templates don't include this XAML file, so you actually have to create it manually. It's worth mentioning that the file names app.xaml and app.xaml.cs are just used by convention, not actually required. Likewise, the class name app is used by convention, but it can actually be anything you want. Resources that you define in your application's dictionary are available throughout your entire application, and you can use static resource or dynamic resource to access them. Interestingly, each resource dictionary is independent, which means the same key could be used in more than one dictionary. And it's not an error if the same key appears in multiple dictionaries on the search path. The resource associated with the first matching key on the path is the one that's going to be used. It's now time for a group exercise. And this will be exercise 6 in your downloadable resources. So if we just open up the Start Here page, then navigate down to exercise 6. And what our goal here is to make our resources available across multiple pages. And we're going to do that by moving them to a resource dictionary in your application class. Let's have a look at the steps involved. So the first thing we're going to do is we're going to create our app.xaml and our app.xaml.cs file in our tip calculator project. And those new files are going to replace our existing application class. And basically the code behind will be the same as the old file, but we have to also add in the initialize component in there. We're then going to add a resource dictionary into our app.xaml. Then we're going to move our styles from our standard tip page.xaml over to our application XAML. And then we're going to apply those styles to a few elements in our custom tip page. So now let's go over and open up part 5 completed. And we'll open up the tip calculator application. So the first thing that we're going to want to do is actually copy the styles from our standard tip page and copy those across to our custom tip page. So let's apply the styles to the label here. And we'll do it with a style equals static resource, and then put our info label style in here. We can now do away with our font size and our font attributes because they're defined by the style. And we'll just do the same thing for the other labels as well. So if we go ahead and set our iOS as a startup project and launch that up in the iOS 5S 8.3 simulator, we can see we have the styles on the standard tip page. But if we try and go to the custom calculator, we'll get an exception error. Okay, and that makes sense because the style info label style isn't defined within our custom tip page. So what we're going to want to do is we're now going to want to move that to our application dictionary. So the first thing we'll do is we'll copy out the contents of our current application page. Then we'll actually go ahead and delete that page. And then we'll add in a new Xamarin.Forms content page XAML. And we'll call that app to replace the one that we just deleted. So now let's go into the app.cs page, the app.xaml.cs page, and replace that with the content that we had before. The things to notice is that it's an application page, but also we need to remember to include the initialize component call in here. Let's go over to the app.xaml file. The first thing we need to do is we need to change this from a content page to an application page. Now we'll go ahead and add an application resources element. And inside that, a resources dictionary or resource dictionary. And now let's go and copy those styles from the standard tip page over to our application page. So we'll copy out these two styles or cut them out of here and then paste them into our application-wide dictionary. Okay, let's run that. Oops. Okay, you've got to set your application page as a partial. Now let's try that again. And here we can see that if we go to our custom calculator, we've now got those styles from the application-wide dictionary. So just to summarize there what we did, we created the styles, or we created a new application dictionary, we added in an application-wide resource dictionary, and then copied the styles across and made them available to every page in our application. Placing implicit styles at the application level helps with sharing, but it can also obscure which styles are applied on each page. So here's one technique that can make things a little bit more clear. Use explicit styles at the application level, then define an implicit style on each page and have the implicit style based on the application level style, and then don't add any setters to the page level implicit style. Its purpose is simply to convert an explicit application level style to an implicit page level style. This also allows new styles to be defined which are based on the application level. And if the application level styles were implicit, then it wouldn't be possible to customize it because, as of today, there's no way to define a style based on an implicit style. So you now have all the tools you need to organize your resources. You can put resources exactly where they're needed, on a specific page, or even in the global app dictionary. And now on to our last objective. So operating systems generally let the user select a few system-wide display preferences, the most obvious one being text size. So this part shows us how to incorporate these settings into your application. So here you'll see how to work with the built-in styles that let you incorporate device settings into your application. And operating systems let users choose device-wide preferences. The most common setting is text size. So users would likely appreciate it if your app UI incorporated their device-wide preferences, for example their preferred text size, onto your labels, but also updated immediately when they change their preferences, so you don't have to restart the application. Xamarin.Forms gives you several predefined styles typically called the built-in styles. And the built-in styles are generated via code at app startup. If the user changes their device-wide preferences, the system styles are updated. The built-in styles are generated via code, and the style objects are stored in device.styles. So styles is a class nested inside the devices class. But this is mostly just implementation detail that you'd rarely need to actually know about. The built-in styles target the label class. The main goal is to let your app incorporate the user's choice for text size. The details for the built-in styles are actually a bit subject to change and may vary based on the operating system. At the moment though, the styles attempt to get only a few values from the operating system, for example the font size, the font family, and the text color. The device.styles class defines a string that identifies each of the built-in styles. These strings are important to know because you use them in your XAML to identify a built-in style. To apply a built-in style, you use the dynamic resource and the value of the style key. If you were to use static resource to attempt to access a built-in style, it'd actually end up yielding a runtime exception. The base resource key is an alternate way to set the Basedon style and is required when working with built-in styles as your base. It's very similar to the dynamic resource. It maintains a link to the underlying style, so when it's changed, the change propagates through to your derived style. You actually can't set Basedon to a dynamic resource because it's not a bindable property, and style doesn't derive from bindable object. The use of base resource key isn't exclusive to built-in styles. You can actually use it in your own styles if needed. So for example, suppose your base style was dynamically generated, so it was not available at startup. Using Basedon wouldn't work in this case, since it only supports static resource. Another example would be, if you want your base style to change dynamically, you could write code to remove or replace the base style in the dictionary, and with base resource key, all your derived styles will automatically update when this happens. It's time now for a flash quiz to test our knowledge. Question 1. The built-in styles work with A, a label, B, entries, C, list view, or D, all of the above. And the correct answer is A, labels. Second question. The built-in styles generally set A, text properties, or B, layout properties. And the correct answer is A, text properties. So you now know how to incorporate the user's device-wide preferences into your application. And Xamarin.Forms does most of the work for you by querying the operating system for the user's preferences and then exposing them to you as styles. And that brings us to the end of XAM140 on resources and styles. Thanks very much for listening. I hope you found something useful in here, and I hope to see you on future classes.